Hi, in this video we are discussing what is a decision tree, how the decision tree can be constructed, how the internal calculations are there, what are the different types of decision tree into details. So let us go for the first topic in this particular video. At first, we should define what is a decision tree. A decision tree is a decision support tool that uses a tree-like model of decisions and their possible consequences, including chance event outcomes and resource costs and utility. It is one way to display an algorithm that only contains conditional control statements. Decision trees are commonly used in operation research and specifically in decision analysis to help identify a strategy most likely to reach to a goal. And also it is a very popular tool in our machine learning. So in this particular document we are discussing three terminologies. One is the information gain, another one is the impurity or entropy, and the last one is the gain. So let us start with the information gain here. We want to determine which attribute in a given set of training feature vectors is most useful for discriminating between the classes to be learned. So that is the first thing we want to find out, that which is the feature with the help of which you can go for the discrimination between the classes of the outcome. Information gain tells us how important a given attribute of the feature vectors is. The last point is that we will use it to decide the ordering of attributes in the nodes of a decision tree. So we'll be discussing a lot on this to have the better idea. But for the timing, just remember this one, that in case of decision tree, on which feature attribute we are going to go for the discriminating regarding the outcome, so that will be decided by the information gain related with that feature attribute. Now we are going for impurity or entropy. It measures the level of impurity in a group of examples. Just consider this one. Here we are having the very impure group. Is very difficult to classify because here we can find that two outcomes, two classes are getting mixed up in a very impure way. Here we are having the less impurity here, and here we are having the minimum impurity, because in this particular class we are getting only one, in this particular section we are getting only one class is there, only the green dots, no plus signs are there. But just consider this particular section, you are having the mixer of the green dots and also this plus signs. So two classes have got there, but obviously here these green dots are having more frequency higher compared to this particular crosses are there, plus signs are there. So that's why it is to some extent having the less impurity and to some extent more decisive. But here you can find that almost the green dots and this plus signs, so both of them are having the same count, almost the same count. So that's why it is very impure to decide the outcome. So how to calculate the information gain? So IPN, what is the P? That is the number of positive outcomes and n is the number of negative outcomes. So is equal to minus p by p plus n log of p by p plus n to the base 2 minus n by p plus n log of n by p plus n to the base 2. So that is a formula to calculate the information gain, and this is a formula to calculate this entropy, and gain is equal to information gain minus entropy. So that is the difference value, and we are getting this one as gain. Now let us take this particular example here. Here we are having day 1, day 2, day 3 up to day 14. We are having the we are having four feature variables, that is the outlook, can have sunny, overcast, rain, three classes. We are having this temperature, it is having hot, mild and cool, so three classes. Humidity, we are having high and normal, two classes. We are having the wind, which is having weak and strong, two classes are there. And there is a outcome variable, there is a play, where we are having two classes, that is no and yes. Obviously in this case we can apply this decision tree for this particular decisive case. Now here we are having some test rows are there. You can find that this sunny, mild, normal, weak and yes, you see that combination is not present here. And also rain, hot, high, strong and no, this combination is not also present there. So this is my training data set and this is my test data set. So now what to do here? Just see here. We're having this respective data sets are there, and there is a target. These are the predictors. Predictor means the input variables or the feature variables. So now at first we shall go for this output. So output can have sunny, overcast and rainy, and then sunny. So sunny we can consider the next that is the windy. The next feature variable windy. Windy is having only two outcomes. So we're having two classes, that is the false and true. And then we're having this humidity under this rainy. And this humidity is having how many classes are there? Here we are having only two classes, that is high and normal. So high and normal. So in this way this particular decision tree has been formed. In this particular discussion we are not discussing that how this decision tree is getting formed, and also we are not discussing why this output should be considered as a first feature variable to go for the discrimination for sunny, overcast and rainy. Why you are taking this one, that we are not considering here, that we will be discussing in our later sections. So that is my one decision tree. Now just apply this one, sunny, mild, normal, weak. What the outcome you are going to get? So outlook sunny, I'm just coming down here, and windy we are having here, the windy we are having here say weak. So what is the weak here? We are getting this one as wind is there, so we're going for true and false, and this weak is actually indicating the false here. So just come to this, and then we're having this one as yes. So that is the case. Next one, rain, hot, high and strong. So rain, so we are going for this outlook. So outlook is having the rain, so now we are going for this rainy. Then we are going for this humidity is high, so we are going for this, and we are getting this one as no. So in this way I've just shown you that how this unseen inputs can have the outcomes here from this decision tree here. So I think the things are getting clear to you. So now let us go for more discussion on this tree construction. In this calculation, in this MS Excel file, we shall discuss how to calculate information gain, entropy and gain on this particular data set, and how the tree can be constructed at first partially and then fully. Okay, now let us introduce our data set at first. We are having four feature attributes: outlook, temperature, humidity and wind. Outlook is having sunny, overcast, rain, 3 classes. Temperature is having hot, mild and cold, 3 classes. Humidity is having high and normal, 2 classes, and wind is having strong and weak, 2 classes are there. Play is having 2 classes, that is yes and no. So now we are having 14 such records are there. Okay, we are having this particular yes count, so that is a positive count or yes count. So here we are having in the outcome 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 yes counts, 14 rows are there. So 14 minus 9, 5 no counts are there. And then we are having the total number of rows is equal to 14. So in this way we have done the respective counting. So here we have used some formulas, MS Excel formulas, to calculate this no and yes using this countif function, and then we are going for the sum. Okay, now for this outlook, we are having this sunny, overcast, rain, temperature 3 classes, humidity 3 classes, so strong, wind is 3 classes. So first column is clear to us. So here we are having the positive, we are having the 9 count, negative 5 count. Now let us go for p plus n, that is 14. Now let us go for the information gain here. So what is the information gain? P minus p by p plus n log of p by p plus n to the base 2 minus n by p plus n log of n by p plus n to the base 2. So I've used the same formula here. So this by this, so minus this by this into log of this by this to the base 2. You can find that we are using the same here, and then we are having this n by p plus n, so that is a 5 by 14 into log of 5 by 14 to the base 2. So though if you are not expert in Excel, need not to bother, just see we have put these values here in this particular formula, and we are getting the information gain as this one. Now for sunny, okay, for sunny, so for sunny, how many yes and how many no's? So 2 sunnies are there, 2 no's, then we are having 2 sunnies, 1 no, so 1 yes, so 3 no's, 1 yes. We are having 1 sunny, another yes, so 3 no's, 2 yes. Okay, so that we are having the 2 yes and 3 no's, so count is here 5. Similarly for overcast, for rain, we are calculating the information gain out of this. So this by this minus this by this into log of this by this to the base 2 minus this by this and then log of this by this to the base 2. So in this way we have calculated the same. You can see the formula here, and whenever you are finding that one of the p or n count is 0, just write information gain is equal to 0. Say for rain also, so just go for rain here. So how many times rain? 3 times rain. We are having 2 yes and 1 no. Then another rain, so 1 yes, so we are having 2 yes and 1 no, so we are having 3 yes and 1 no. We are having another no, so 3 yes and 2 no's. So 3 yes and 2 no's. So in this way you are getting the count is sum is 5, and we are calculating this information gain. So in this way we have done all these calculations. You see, we have done all these calculations are there. in this case. We've done all the calculations like this. Okay, done. Next, we are going for the entropy calculation. So what is the entropy equation? Entropy equation is this one: Pi plus Ni by P plus N into information gain of Pi Ni. So see how we are calculating the same. So here we are having this, and that is a Pi. So there is a Pi plus Ni. So this one Pi plus Ni, but by P plus N. So 5 by 14 into information gain, then 4 by 14 into information gain, then 5 by 14 into information gain. So you can find that we have written the formula just exactly in the same way. Okay, so that is the way to calculate the entropy. So here also we have calculated entropy for temperature. Here also we calculated entropy for humidity. Here also we have calculated entropy for wind. So same kind of formula we have used here. So now we shall go for the gain. What is the gain? Information gain minus entropy calculated. So that is here where we are going for the gain. So that is information gain minus the entropy calculated. See, we are taking this information gain for this and then entropy calculated. So in this way we are going for this. So which one is having the maximum value? Just let me know. We are having this one, that is a 0.24675. So it is having the gain is maximum. So what will happen? We shall go for the discrimination. We shall go for the classes under this outlook as a fast decisive logic. So as a result of that, we are getting the corresponding decision tree formed up to this level. Now we are going for the next. So now here we are having the sunny, then overcast, and the last one is the rain. So here we have taken the sunny, here we have taken the overcast, here we have taken the rain. So how many times sunny has occurred? So 1, 2, 3, 4, 5 times. So you can find that 5 records are there. So how many times overcast? We are having 1, 2, 3, 4. For 4 times overcast. So 4 overcast records are there. And rain 6, rain 5, I think. Yes, it is 5. So let me go for this here. So we are having this rain 3 and then 4 and then 5. Yes. So we have extracted only those records where outlook is equal to sunny, outlook is equal to overcast, and outlook is equal to rain. So now see for this one, how many P's and N's we are having here for the sunny temperature. So for the sunny temperature, sunny humidity, and sunny wind. So temperature is having 3 classes are there. Sunny humidity is having 2 classes are there, and sunny wind it is having 2 classes are there. So here we are calculating the respective positive and negative. So you see, so for hot we are having no, hot we are having no. So we are having 2 no's and 0 yes. So these are mild and these are respective cool here. So in this way we have calculated the same. Just go on adding them. 2 plus 2 plus 1. What is that? That is about 5 here. Here also you can go on adding them. You just go on adding them. So now just go for this. 5 plus 4 plus 5. What is that? 14. 4 plus 6 plus 4. What is that? 14. In this we can find that for each one of them, for each category, temperature, humidity, and wind, we are having the sum of P plus N is 14 here. And that is quite obvious. Okay, so we have done up to this. So now we will be calculating the information gain. I told you that whenever the P count or N count, any1 is 0, so information gain will be 0. Whenever they are equal, information gain will be 1. Whenever one of the values will be 0, so it will be 0. Here it will be 0. Here it will be 0. Both values are 1. So here the value will be 1. 1 and 2. We have calculated the information gain accordingly. Okay. Now we shall calculate the entropy now. So how to calculate the entropy? See, entropy will be calculated, you see, taking this one, 2 by 14. So you see, we are calculating this one, 2 by 14. So 2 by 14 into, that is into L29. What is the L29? L29 is this one. There is the information gain by K30 by K11 into L30. So this one. In this way we are calculating this entropy. And while calculating this gain, we are just subtracting this information minus this entropy. We are getting this gain. So similarly we have done for this. Similarly we have done for this. And then what is the maximum value here? We are finding here that is a 0.94 is the maximum out of them. So this sunny humidity is having the maximum. So how many classes are there under this humidity? We are having high and normal. So 0, 3 and 2, 0. So 0, 3 means there is no ambiguity. So here the classification is very pure. So what is happening? So I shall be going for no. So when the sunny humidity is high, I shall go for no. When the sunny humidity is normal, then I shall go for yes. So for high, no. For normal, yes. So we have formed this decision tree up to this level from this one. So there is the update here. Okay, done. Next we are going for the overcast. In case of overcast, you can finding that all the outcomes are yes. So that's why we can easily form the next one, that is the yes. We are taking this one as yes. Okay, next we are going for this rain. So rain temperature, rain humidity, rain wind. So we are going for the same thing like as we have done here. So here finding that the gain is this one, so you can find that we are calculating in this way. I'm just showing that which of the cells are participating in the calculation. See, so now we are getting this, and to gain, so we are having this entropy minus, so this information gain minus entropy, you are getting the same. Okay, so here the gain is maximum here for rain, wind. So how many classes are there? Strong and weak. So strong means what? Only no. Weak means what? Only yes. So here also we can go for the respective one. So rain, weak, yes, and rain, strong, no. So you can find that all of them have got the leaf nodes, either filled up with no or yes values. So now you can find that we have got the respective calculations here. This decision tree can be formed using two types. The first type is the algo and the split criterion can be the Gini split or the Gini index. So Gini split or Gini index, and here we are having the tree type will be the cart, and cart is having the full form, that is a classification and regression trees. So description is that it favors larger partitions and very simple to implement. Next we are going for the information gain or entropy. So whatever you have done here in this calculation, so favors partitions that have small counts but many distinct values. So here the tree types will be ID3 or C4.5. So here you can find that what are the different types of trees we can form here. So now let us go for another one. So how to calculate this Gini, so Gini index. So the formula is this one. So the Gini index, so A is say we are having one data set we are going to discuss now. So there the A category will be of 243 number of, B category will be of 89 number of. So total is 332. So Gini index can be calculated using this formula. What is the formula here? There is 1 minus, yes, there is a 1 minus. So there is a I57. So this one by I59, there is a square of that plus I58, so I means this I column and 58 means this row 58 by I59 square of that. So in this way we can calculate the Gini index, and here the Gini index is 0.392. So you'll be getting all these things. I'm just I've done the calculation here, but I'll be use that one in the next session of my videos. So you can find that here we have calculated everything using Excel. Manually we have calculated, so we have done all the calculations manually, and we have shown you that how the tree is getting formed out of them. In this Python implementation code, we shall show you that how to implement a decision tree of the type of cart, that is classification and regression trees. So here we'll be using our pandas, the module, that is a import pandas as PD, because here we are going to use a data frame. Our dataset name is dt_data.csv. So let us introduce our dataset at first, then we shall populate our data frame accordingly. So we are going for the dataset. So now let us go for the dataset here. So here we are having the dataset. We are having the customer ID. So I'm just going for a little bit zoom. So here we are having the customer ID, gender, education level. One column is blank, so 1 2 3 4 or 0 1 2 3. If you consider the first column with the index 0, then we are having this one as the index 3, so that this column is blank. And then we are having the month, last month spent, last 3 months average spent, and spent drop over 50%. So here we are having this outcome column filled up with 1 and zeros and ones. So this is my numeric, this categorical blank column, and then these two are again numeric columns are there. Okay, so just get my data set. So now we're having this one. How many records are there? 475 number of records are there. 475, because one row has been occupied for the column head. So 475 number of records are there. So that is our data set. So now let us go for more detailing on this coding. So pd.readcsv. So readcsv is a method with the help of which you are reading this particular CSV file. CSV is having the full form, that is comma separated values. So the comma separated values, you can find that in the Excel it is showing in the grid form, but actually if you open the same file in Notepad or any other text editor, you can find that the values are separated by commas only. So now these are data frame binary dot head, so it will print the first 5 rows of the data frame. So this is a grid view, so it is easier for us to handle, and also the columns heads are coming bold, and here we're having the banded rows and so on. So that's why we prefer to use the grid view using this data frame. So we're having the customer ID, then this is my gender, there's a categorical, there's also the education level categorical, unnamed 3, so there is a column name given by this pandas read CSV. So that's why it is the NN, not a number. We're having the last month spent, so that is the numeric. Last 3 months average spent, so that is my numeric, and spent drop over 50%, that is my 0 and 1 column filled up. So that is also numeric. So now let me explore my data. So if we go for the binary dot describe, what is the binary? That is the data frame name. We are getting all these details about the count, that means the total number of 475. I told you this one earlier. We are having the mean value, standard deviations, mean, so there is the first quartile 25%, second quartile, that is the 50%, also known as median, 75%, that is the third quartile, and maximum value against this column is there. So they are available only for the numeric fields, but for the categorical fields, so these values are not available. So we are not getting all the column heads accordingly. We are getting only those column heads which are numeric. Now we are going for the there is a binary.dtypes.index. You can find that we are having this one as customer card, customer ID, gender, education level, and there is a unnamed colon blank space 3. So that is very important. So from this data frame, so from this particular data frame, I'm just dropping the unnamed 3, axis 1, that is a columnar. From the axis 1, there is a columnar, and that is my in place is equal to true. So my data frame is getting updated accordingly. So binary dot data types dtypes dot index, you can find that there is an unnamed colon blank space 3. So that column has got deleted permanently. Why it has got deleted from the data frame? Because we wrote this one in place is equal to true. What is axis is equal to 1? Columnar, that is vertically the respective values will be deleted. Next we are taking this, we are just considering 0 1 to A and B. So 0 will be replaced by A and 1 will be replaced by B, and in place is equal to true. So the update will be done in the data frame itself. So that's why you can find that it is coming as B A A A A. So just see, in the previous case I had the output as 1 0 0 0 0. So in this way, for the first 5 rows we are getting this one as B A A A A. In this way the things are coming. Now I want to count that how many A's and how many B's are there. So that is a 350 number of A's and 125 number of B's are there. So please remember this count. So A is 350 and B is equal to 125. So just go on adding, we are getting this one as 475 as usual. So now we are going for the round. There is a binary dot spend drop over 50% dot value counts. So that is a percent, that is into 100 by lane of this, and you are going to calculate it up to the second decimal place. So what is this? We are getting the percentage of occurrence of A and percentage of occurrence of B. If you go on adding, obviously we are going to get 100, because 100 is the full percentage. So that's why you're getting this. Here you are getting this them as in counts, and here you are going for to getting them in terms of percentages. Now I shall go for the split of the test and trend sample. So now we have a data sample which can be considered for the modeling. We are splitting the data into test sample, which will be used for validating the model developed, and trend sample, which will be used for the model development. So now let us go for the trend test split, the respective method to be called. So now you can find that there is a split sample into trend and test, and from sklearn.model selection you are importing trend test split, this very class. So you are defining one class object. Here we are having this trend and test. So there is a test split we are finding here. We are finding this, we are just passing this binary, and test size is 30%. So trend size will be 70%. Random state is equal to 176. So there is a seed value we are passing for the random number generation, and we are getting this trend and this test. What is the trend? That is a data frame. What is the test? There is also another data frame. So trend and test data frame, we are getting this one. So we are having this trend dot head. You can find that it is just it is the 70% of the record sets. Okay, so here you can find that this IDs are different and IDs are coming very haphazardly. So that's why this particular splitting has been done depending upon this random state value randomly. So now we are taking all the rows but column number 3 and 4. You know that 3:5 means 5 is always exclusive. The ending subscript or index number is always exclusive and starting one is inclusive. So actually you are taking the third and fourth row, third and fourth column, and taking all the rows. Colon means all the rows. So let me check once. 0, 1, 2, 3 and 4. So it is taking these two numeric columns. Okay, for train independent bars, and 10 target bars it is taking all the rows but the column index number 5. Just check here, 0, 1, 2, 3, 4, 5. Yes, so this output column is this one. So that we are putting in train target bar. So train independent bars, it is printing this 20, 30, 790, 780. It is printing in this way. So 20, 30, 790, 780. It is printing in this way, and here we'll be having B A A A B. So this is my independent bar. Now we shall also check the train dependent bar. So here we are having this one as B A A A B. So in this way you are getting this output. Now how many rows are there in total? We are having the 332 rows. So how many A rows are there? We are having 243 rows. How many B rows are there? We are having 89 rows. What is 332? So that is nothing but almost 70% of that is the total row count. There is a 70% of the total row count. Okay, I think you are getting my point, because just I'm going for the recheck once that how this 70% is coming. You see, we're taking this test data set as 30%, so 70% is going for the train, and total count is 475. So if you go for this 475, if you go for this 475 and 70% of that will be coming very much close to this value, that is the 332. Out of this 332 we are having A rows as 243 and B rows as 89. So now here we are having the decision tree classifier, and we are defining one object, that is the DT train Genie. So we are having this one. So criterion is equal to Genie. So Genie means we are going to define the cart type of decision tree, that is classification and regression trees. So we are having the random state is equal to 100, max depth is equal to 5. Remember, this one will be reflecting the same in my in our output. So mean sample leaf is equal to 5 here. So that means the mean sample leaf is equal to 5. So these parameters, just remember them. I shall explain it in the graph. And now after making this decision tree ready, so we are going for dt train underscore genie dot fit. So what is this? This is nothing but decision tree classifier object. Dot fit means you are making the model trend. So what you are passing? You are passing the capital X and the small y. So that is a train independent bars and train target bars. So whatever the parameters we have passed, we can find that they are reflecting here. Max depth is equal to 5, you can find here. Random state is equal to 100, you are getting this one. Criterion is equal to Genie, you are getting this one. And also the max depth is equal to 5, also you are getting that max depth is equal to 5 here. And rest it is taking the default arguments. Now what we are doing, we are just making them available in one file, that is a dt underscore train underscore genie.txt. In the write mode, we are just creating this file, and this file will be created using this one, that is a f is equal to tree.export graph v's and then dt underscore train underscore genie output file is equal to f. So now what will happen, we are going to get one file here. This is the file dt underscore train underscore genie.txt. You can find that. We are just creating the file here, and it is getting created. So this is a file name. You can give other file name also. File name is not the issue. So now if you go opening this particular file, this is the content of the file. I think the file is not meaningful to us until and unless we draw the graph, draw the tree against this particular value. So what we are doing, we're just copying this one, and then we're just going for, this is our web graphviz.com, and here we're just pasting the content of that text file, and then we shall go for generate graph. You can find that the decision tree has got formed here very clearly. The decision tree has got formed here. So now they are considering x0. Now tell me how many attributes we considered in capital X? 2 attributes. What will be the index of the first attribute? 0. So it is just this graph has been formed. So now you see x0 is less than equal to 75. So it is putting that criteria, and Gini here is 0.392. So there is a Gini value they have calculated. So this particular Gini value we can also get it done from the respective calculations. We can find here we are having this is a respective data set. Okay, so let me go for the let me open the calculation here. So that is very simple. So here is the calculation for us. We know that A is having this count for 243, B is having the count 89, and total is 332. So how to calculate the Gini index? So that is a formula here. So how to calculate the Gini index? So it is nothing but 1 minus, there is a 243 by 1, there is a 332 square plus 89 by 332 square. So in this way you are calculating this Gini index. So what is the value here? 0.392. So you are getting this value. Okay, so now let me go for the graph here. You can find that there is a 0.392. In this way, for all cases the Gini index value has got calculated in this way. So how many samples are there? We are having 332. How many of them for A? That is a 243. How many of them for B? That is a 89. We did the calculations, everything in our Python code. So this criteria is getting satisfied. So for those cases you will come into this true arm, and the right arm is having the label false for all the cases. Okay, so left arm will have it the label true when the condition is true, and right arm the control will be flowing to this particular node of this decision tree when the condition will be false here. So similarly it is going for doing all these things accordingly. I think you are getting my point. So these are the conditions are getting set by the respective decision tree, the respective classifier, and the tree has got generated. Now you can find that we are having these are level number 0, 1, 2, 3, 4, 5. You see the maximum depth is 5 here. You can find here, and also you can find that why this 2 and 3 it has not got splitted again, because I wrote that is a minimum sample leaf is equal to 5. So both of them are below 5, so that's why it is not going to get splitted. 0 and 8 it should not be getting splitted, because you know that 0 means it is a pure class. That means the 0 number of A occurrence and 8 number of B occurrences. So 8 outcome will be B, its outcome will be A. So that's why it has got no splitted, because there is no need to go for splitting, because here the classification is very much homogeneous. We are having 10 number of A's and 0 number of B's, but here both the values are more than 5, so that's why they got splitted. So I think you are getting my point, why when we are stopping splitting and when you are going for splitting. So that we are having this one here. Obviously the decision tree is getting formed with some constraints. We are having the maximum depth, we are having the min sample leaf values are defined. So in this way the tree can be formed. So now I think you are handy with the coding. So we have shown you that how the tree code, the Python codes are to be written, and how the tree which will be generated on a text file. The data will be put on this webgraphviz.com. You can just look at this URL webgraphviz.com, and there you are putting the content there, doing the copy and paste there, and go for generate graph. The graph will be generated. I have explained each and every parameter of this graph. I think now the concept is now getting clear to you. Here we have used the cart type. Thanks for watching this video.